Hi there, grade 11s. This is to explain the difference between free body diagrams and force diagrams on page 21 in the textbook. Right, this line is too wide. I need to make it narrower. How will I do that? Can't. Right, so example 4 has an object, a box there. Sorry for my untidy work now. That is resting on a horizontal, a flat surface. Now the forces that are acting on this box would be the weight. So the weight is the gravitational force, Fg. There is an applied force that pulls up like that. That is 100 newtons applied force, F applied. And the other forces that will be acting on this object would be the force of the surface on the object that acts perpendicular to the surface. That is called the normal force. And there is also a frictional force between the object and the surface that runs to the left. I guess this object would be moving to the right. That is why the frictional force would be to the left. Now, this is a free body diagram. It shows all the forces acting on the object and most probably where it's acting on the object. Sorry, this is a force diagram. A force diagram. Now, a free body diagram ties all these forces at their tails. Free body diagram. So it takes the weight, it reduces the object to a dot. It takes the weight's tail and attaches it to the applied force tail and to the normal force's tail and to the frictional force's tail. So this is the free body diagram. Now you could draw the free body diagram by using the components of the applied force, but you can't draw the free body diagram using the applied force, showing it on the diagram as well as the components, the perpendicular components. Now, we discussed the components of a force in class the other day. The x component of the free body of the applied force would be this one, FAX, and the y component would be here, the way we did it in class the other day. But in a free body diagram, the tails must be joined. So I can't draw the y component here. I've got to draw it here. F-A-Y. So you have an option with a free body diagram if there is an applied force or any force, a tension that's got x and y components. You may draw the force like I had it, like that, or you may draw it as its components. I think this should be explaining the question that was put to me. the health question that was put to me. And example 5 on page 21, the applied force is acting down. So I can change this. The applied force is acting at an angle downwards, like this, sorry, like that. That is now the applied force. If the object is moving to the right, the frictional force will still be to the left. The friction opposes the motion. Then the free body diagram will change in a sense that the applied force tail joined to the other force's tail would do this. The applied force will act in that direction. Sorry, I need to label these forces. That's the friction. This is the weight, the gravitational force, and this would be the applied force. And in example 5, it's also 100 newtons to 30 degrees to the horizontal or the x-axis. Now, if you want to not use the applied force but its components, then you can't show the applied force like that. You have to show the components only, and the components, the x component would be in that direction, F applied x, and the y component would be in this direction, F applied y. Now you can't draw these arrows on top of each other. You've got to draw them next to each other. So my advice is that you change the dot, the object, to something a little bit bigger so that you can fit in all these forces that you want to join at their tails. Right, I hope this explains the situation on page 21 in your textbook.